Good afternoon, everyone, and thank you for joining today's Astadia and Cloud Endure webinar featuring high-grade, low-cost disaster recovery strategies. During the presentation, if you have any questions, feel free to type it into your chat box on your control panel, and we'll save it for the end of the presentation. We have an interesting presentation in store for you today, so let's get started. Alan Alvarez, I'll hand it over to you.
Thank you, Desiree. So in today's webinar, we're going to talk about Astadia's Disaster Recovery as a Service, how high-grade, low-cost disaster recovery strategy. My name is Alan Alvarez. I am a Senior Cloud Architect here in Astadia, and with us today, we also have Gonan Stein. He is the VP of Business Development at Cloud Endure. So to start off in the agenda, I'm going to give a quick sales pitch, introduction to Astadia. I'm going to talk about what is a disaster recovery as a service, talk about a disaster recovery roadmap and the different services. I'm going to give a quick overview of Astadia and Cloud Endure's partnership, and that is where I will hand it over to Gonan, where he is going to talk a little bit more detail about Cloud Endure and give a quick demo of Cloud Endure and what it can do. And then Desiree is going to talk to us about a special offer that we have going on right now. And then towards the end of this webinar, we're going to have a Q&A session where you please submit your questions in the webinar portal, and we will answer them as they come in at the end of the meeting. Okay, so to get started, for those that don't know us, Astadia is a full-service technology consulting firm that offers a full stack of IT services, focusing on maximizing impact and minimizing risk for our customers. We help customers navigate today's ever-growing complex ecosystems with a blend of applications and services for either on-premise, hybrid, or public cloud solutions. The full stack of services that Astadia provides include cloud assessments, migrations, legacy workload modernizations, DevOps, and a full stack of managed services. So Stadia has been working on managed services and legacy modernizations for 25 years, and our clients choose us for our experience, agility, and results. We pride ourselves in being agile, that's the highlight, and flexible, to be able to work the way that your organization likes to do things. Most importantly, we deliver results for being so agile and flexible. Our goal is for every one of our clients to be a reference for us. Over Astadia's 25 years of legacy modernizations and managed services, we have developed what we call the Astadia Solution Success Methodology, where we will work with customers to envision a solution, help customers define requirements, create the solution to meet the needs, deliver the solution, apply managed services to that final product, and then optimize that solution. And all of this while taking advantage of today's elastic performance, scalability, and most of all, agility of today's ecosystems. As you can see, Stadia provides a full stack of IT services and managed services, everywhere from cloud assessments, cloud monitoring, cloud migrations and deployments, cost optimizations, security, support, infrastructure operations management, and for today's webinar, we're going to be covering disaster recovery. So very quickly, what is a disaster recovery as a service? And we hear that a lot nowadays in everything as a service. And disaster recovery as a service is a comprehensive portfolio of services that enable business operations to continue to function in the event of a disruption of service. And a disruption of service can include, but is not limited to, a failure of a server node, a corruption of an operational system, or a complete loss of a data center. And any kind of downtime or operational downtime can severely impact a company's finances, loss of opportunities, or even lead to a loss of market share. And I really like this quote because it kind of captures the essence of the importance of a DR. It's like backing up your data is not enough. You must back up your environment as well. Okay, and the two most important points when designing a disaster recovery strategy is price point and total cost of ownership. But the two most important technical factors are RTO and RPO. So they stand for recovery time objective and recovery point objective. So RTO is how long can you afford to be down? So the time it would take for you to resume operations. And recovery point objective is how much data loss can you sustain and still be able to resume operations once you're back on. And either one of these can be a week, a day, an hour, minutes, or in some cases, if this system is crucial for your business operations, it can be no downtime whatsoever, no RTO and no RPO. So what is a service? What is a disaster recovery service? And this slide kind of encompasses all of the different factors to consider when designing a disaster recovery and a service. So you have your production environment, your production site, and this can be physical servers, virtualized servers, or a cloud environment. And your disaster recovery site or secondary site, again, can be physical servers, virtualized servers, or a cloud environment. And you have your primary site and your secondary site, and how are you going to replicate data between both sites? And there's different tools to do so. And from the monitoring perspective, the disaster recovery service piece is where you apply some sort of monitoring agent on your source and your target system to make sure that it has a heartbeat. So if an alert is detected by a managed service, what we call a runbook will be deployed to follow the steps to spin up an instance, make sure that it's running to specifications, and that will become your primary site while the original site is being repaired or being remediated. And that secondary site now has to be monitored for security. It needs to be monitored for performance. It needs to be monitored for specifications, making sure that operations are running as expected on that secondary system. And while this is going on, there is a process of remediation on the original site. So we will help customers figure out that remediation. And once that system comes back online, that is where fallback comes back. So that will be replicating any transactions back to that original production site. And then you resume regular business operations and document any kind of things that happened during this scenario, so you can prevent it in future events. And the whole point is to reduce this arrow to be shorter. So you want to make sure that you're not down for a significant point of time, and your spin up and your DR environment don't run longer than expected. So what is the Astadia disaster recovery solution? Again, it is the full stack disaster recovery solution where we will help you analyze the business needs of a DR environment and what level of protection do you need based on how your revenue and services will be impacted by the disruption of service. So what is the cost of a disruption to you? Develop multiple DR scenarios so you can choose what best fits your total cost of ownership and your performance impact considerations. We will design, implement, and test your DR solution. And this is important, is the monitoring and management of your entire DRaaS environment. So that is monitoring your source environments, monitoring your target systems and replication activity, schedule validation testing, and this can be monthly, quarterly, or yearly, depending on your requirements. Support the customer in case of a disaster event, and develop a checklist for success. So always be improving what the functionality of this disaster recovery as a service offering does to you. And through this, our offering portfolio, we have partnered with Cloud Endure for our disaster recovery tool. Then what Cloud Endure brings to the table is a low price tag where data is being replicated at the disk level, not the OS level. And processing engines for your DR site are brought up on demand, so you're not incurring on idle systems. And you don't have to purchase any additional licensings for these DR environments. And you don't have to have any compute units available on your cloud instance. You just spin them on demand. It also brings well-planned orchestration, which means that data is being replicated constantly to your target environment. So that brings near zero recovery point objectives and zero transaction loss, or near zero transaction data loss. And seeing that you're always replicating and you have the cloud, the power of cloud to spin up instances on demand, you have a faster recovery speed. So data, any kind of changes will be propagated to your target environment. Data is constantly being streamed. And again, target instances can be spun up on demand, bringing zero recovery time objective or near zero recovery time objective. And Cloud Endure does dual replication of data. So it will do it to your target system and target to source. So this will help you during the fallback operation to make sure that any kind of transactions that happen during a DR site will get propagated back to your production environment. And to give you a little bit more detail of what Cloud Endure can do and give you a brief demo, I'm going to hand it over to Gonan. Thank you.
All right, thanks, Alan. Thanks so much. So let me go ahead and share my screen here. Okay, great. Everyone should be able to see my screen. So just to quickly introduce myself to everyone. So again, my name is Gonan Stein. I'm the VP of Business Development, and I manage our partnership with Astadia. And what I'll do now during these the next stage of the session today is I'll walk through just a few slides that really talk about what the technology does, how it actually works behind the scenes, in case people are interested. And then I'll also jump into the demo of the product itself. So again, we'll talk about the technology, how things look like from an architectural standpoint, and how the process would actually work, how we can achieve all the different areas of cost reduction that Alan had mentioned, and then we'll show the demo as well. So going back to the technology, right, the way that Cloud Endure works and the reason that we can achieve very aggressive recovery point objectives and recovery time objectives, and the reason that we can bring things up in the cloud quickly with also reducing the cost dramatically is a combination of the different pillars of our technology that you can see here that I'll talk about now. So if you look at Cloud Endure's technology, it's really based on three primary pillars of our capability. And the first one is the replication component. So on the left-hand side, you can see that we have a replication engine. This is Cloud Endure's proprietary intellectual property that we have developed, which conducts continuous replication at the block level, running from the OS itself. Right? So Cloud Endure provides an agent that Astadia can help you deploy, and that the agent will be installed at the Windows or Linux level on any infrastructure. Right? So the fact that it's running at the OS level means that, first of all, we're agnostic to infrastructure. We can protect physical machines and virtual machines running on any hypervisor or cloud-based environments. So you can protect machines even if you're already running them in cloud providers like Amazon or Azure or Google or other areas. And then on top of that, since the replication is conducted at the block level, once the agent is installed, it connects directly to the disk. It is application agnostic as well. So it doesn't matter to us, and there is no skill set required if you want to use Cloud Endure to protect application A versus application B, or even some homegrown application that someone has developed. It really doesn't matter because it's all replicated at the block level, meaning that it really reduces the complexity and human error, eliminates human error from an application perspective. And it's done in a non-disruptive fashion. So the agents are deployed without requiring any kind of system reboot, and they're conducting real-time sync. And real-time means real-time. It's not a periodic replication of changes every 15 minutes or so. It's actually real-time replication, so any transaction that gets committed to the disk is captured in real time by the Cloud Endure agent and replicated to the target location of your choice in a cost-effective way. And that is what provides the near zero RPO, so it's a sub-second RPO range, recovery point objective. And as Alan mentioned before, in addition to allowing you to very simply initiate the replication of your data and fail over to the cloud, it also allows failback. So the same agent can be reversed, the replication can be reversed, and then replicate all the data, same thing at the block level continuously, from the cloud, from the target environment, back into your source environment whenever a disaster is over and you want to go back into your original facilities. So that's the first piece of our technology that makes us very unique. The second piece is the machine conversion. And the machine conversion that you see in the center of the screen is critical, obviously, because you can't just expect a machine that is currently running on-premise on a VMware environment or a physical environment or other hypervisors. You can't just expect it to magically be able to boot and work natively in the cloud because it needs to be converted first. And this includes things like injecting the hypervisor drivers appropriate to the cloud target, and installing the appropriate cloud tools, and handling any kind of OS activation. If it's a Windows server that's now running in the cloud, needs to be reactivated from a licensing point of view, and so on and so forth, networking configuration, etc. And that is what the conversion does. The conversion process is, again, a Cloud Endure intellectual property that goes through that conversion process end-to-end very quickly. In about 30 seconds, that process is done. And this is what allows you to not only recover the data in real time and achieve a very low recovery point objective, but this also allows you to achieve very low recovery time objectives. So within minutes, the entire systems will be back up and running. We can do it in parallel and bring up thousands of machines in the cloud at scale. And this helps you avoid any kind of, again, human error, avoiding rebuilding systems and worrying about compatibility matrices of different machines and applications, because it's all done transparently behind the scenes. And then finally, it's designed in an any-to-any fashion, so it helps you avoid lock-in to any particular infrastructure that you may be running on, if you want to have the flexibility of moving around. And then finally, we have an automated orchestration mechanism that brings everything up at scale. All right, so step one was replicating the data. Step two was, at the time of disaster or DR test, convert the machines transparently and bring them up. And the third aspect here is being able to bring up everything at scale. So if you have hundreds or thousands of machines that you want to recover, you don't want to have to recover them one by one, obviously. So you can define in advance, and this is something that Astadia is well equipped to do as part of providing this service, is design in advance or define in advance where each system belongs, what networking configuration should be associated with each machine and application, and then Cloud Endure will basically act upon that information and bring everything up at the same time in parallel. And that is really cloud scalable. So as long as your target cloud infrastructure can provide you with those resources, which obviously it can very easily, Cloud Endure simply leverages the cloud scalability and brings everything up very quickly and reduces any kind of human error and labor that is involved there. And of course, as I mentioned before, you have then the ability to fail over, plus then fail back if needed. So with that, let's talk about how this actually looks like behind the scenes from an architectural point of view, right? So, and how we can achieve the dramatic cost reduction part of it, as well as the then spin things up very quickly. So this is an example of a typical disaster recovery deployment, protecting different types of applications, some of which could be pretty expensive applications, both from an operating system perspective as well as from an application, a third-party application perspective. So we have a source environment which could be running anywhere. One of the machines is running a Windows server with such and such applications, such as SharePoint or Exchange or Active Directory or anything else that you may be running. And then you can have Oracle machines, or both on the operating system side, or Red Hat machines running expensive applications such as Oracle databases or SAP workloads. It really doesn't matter to Cloud Endure. We support any of those applications. And on the right-hand side, you can see what Cloud Endure does to keep the data in real-time sync while still reducing the cost dramatically. So we have an agent running on every source machine. So agents can be deployed in a non-disruptive fashion. The agents will automatically detect which volumes and how big they are attached to the machines in the source environment, and then automatically begin the replication of data and the auto-provisioning of the target infrastructure in the target cloud of your choice. So for every roughly 10 machines here on the source, we create a tiny Linux-based replication server in the target environment, and that tiny Linux-based replication server is attached to the disks, the volumes, that need to keep the data in sync. And these volumes that we spin up are also cost-effective volumes. Unlike the source volumes, which could have been high-performance volumes, here in that target, we call it a staging area, we don't really need high-performance anything because we're just keeping data in sync, in real-time sync, but it's not really usable at this stage. It's just keeping everything in real-time sync until a disaster strikes, and then I'll talk about what happens then. But until that point, and this is what happens during basically almost all the time throughout the entire year, you're not going to go through disasters every day. And why should you pay for a warm standby or hot standby of your machines if you don't really need them? This is what Cloud Endure really brings to the table from a cost reduction standpoint, because we're just keeping the minimal infrastructure as minimal as we can get away with to keep everything in sync. And this results easily in 95% cost reduction from a compute standpoint, because you don't need the actual expensive instances running in a warm standby. From a storage point of view, again, conservatively speaking, we can save at least 70% because of the types of disks that we use here on the right to keep the data in sync. Anything having to do with operating system licenses like Windows licenses or Red Hat licenses, or third-party applications, software like SharePoint or Oracle databases or anything else, any other applications, that's completely eliminated as well, because there's nothing running in the target environment here from an operating system, from a paid operating system, or from an application standpoint, right? This is just a free OS Linux machine, and the applications are not running at all, right? We're just keeping data in sync. So complete 100% cost reduction from an OS and application perspective. And of course, in the cloud, there is also no cost associated with defining your networking in advance. For an example of Amazon, for example, you have VPCs and subnets. There's no payment for those until you actually bring up machines in them, unlike a traditional on-premise infrastructure where you definitely have to pay for your routers and switches in advance in your DR site. So having said all that, right, we still provide continuous replication using those lightweight servers with sub-second RPOs. And this is what's going to be provisioned and used throughout the entire year until you have a disaster. Once you have a disaster, here's what happens. I'll skip to the next slide. You can see here the Cloud Endure now automatically takes the volumes from that staging area, that low-cost staging area that's not really functional. When a disaster strikes, we take the most current version of those volumes up down to the second, the most up-to-date state down to the second, and reconstruct those volumes attached to the actual instances that need to run the machines going forward. So now we bring them up, we attach them to Windows servers, to the appropriate Linux servers. All the applications will be intact because we've replicated everything at the block level, and everything is accessible via a DR dashboard. So you can log into a web-based console given at any point in time and see what's going on, what the status is of the replication, what's your RPO, and when you want to bring things up, the RTO will be measured in minutes because everything will be spun up very quickly. Using Cloud Endure, you can perform an unlimited number of non-disruptive tests through any given point in time. Stadia can also help you with that. And once disaster is over, then you can fail back as well. So now we have everything running in the cloud. Everyone's happy because you have a disaster and now you've redirected everything to the cloud. And once the source facility is back up and running and you're ready to bring everything back, then you can simply reverse the replication direction from these cloud-based systems into the on-premise systems that we've seen in the previous slide. All right, so basically everything gets replicated to the cloud, spun up in the cloud whenever disaster strikes. When we're spinning up the machines in the cloud, you can see that they're actually spun up with the Cloud Endure agent already running on them in the dormant state, just waiting to hear when it should start replicating the data back. And when the source environment is back up and running or back available, then the agents can be instructed to reverse replication direction in order to fail back everything into the on-premise facility. So that's how the architecture looks like, and how, basically the two components of, or the two stages of replicating everything before a disaster strikes, and then what happens after a disaster strikes in order to recover and be up and running very quickly. So with that, let me now take a quick pause and jump into the demo. And after the demo, we can open it up for any questions. And of course, if anyone has any other questions, feel free to chime in the chat box, and we can address the questions after the demo is over. Okay, great. So everyone should be able to see my DR console now. I have a Chrome browser open up with the Cloud Endure dashboard, the DR dashboard. And specifically what we see here is an environment where I'm replicating workloads from the source site, from the source location into a target location of another target location of my choice. In my case here, I'm replicating into Amazon Ireland as a target. And we see here that we have a list of different applications, different servers that I have currently protected by the Cloud Endure agent. And this list will be populated by any agents that you deploy. So in my example here, we have 3 machines that I've deployed with the Cloud Endure agent, and therefore these 3 machines appear in the console. And they will appear here pretty much immediately after the agent is deployed. Right? Registers with the service, and you see what's going on. Now, the initial state that a server shows up with whenever the agent is deployed is initial data replication. So that's the stage where the Cloud Endure agent will read all the data from the disk or from the multiple disks attached to the machine and begin replicating the data into that lightweight staging area in the cloud. And once the replication is complete, it will then change the status to continuous data protection. Continuous data protection, which all these servers are now at the status of, indicates that the initial sync has completed at some point in the past, and now every new transaction that is being committed to the disks is being captured in real time and replicated to the target location of your choice in a cost-effective fashion. So let's take a quick example here of what happens in a disaster. Right? So these applications are now happily running, everything's fine. Let's access one of those applications. So I've got, in my case here, I've got a 2-tiered app comprised of a demo front-end server. This FE stands for front-end web application. BE is my back-end database. So let's access my front-end application, and there's a source tab here that shows some of the information about that source machine. So in my case, I'll just grab the IP address and access that IP address. Let's make some changes to my application, my live running application in real time. So again, it's a blog site running on WordPress. I can go ahead, you can see it's a live running site. If I click new and create a new post, let's put in Astadia and Cloud Endure, DR webinar, and business running as usual. So let's publish that. And again, this simulates any kind of transaction that you would have during ongoing protection, during standard operation where everything's functioning well. And now this is just another transaction that was committed to the database. So here it is, real-time live update. If I go back to the Cloud Endure console, you'll see that both this individual machine, if I look at it from the inside of that properties tab, shows that it's still under continuous data protection mode because everything's up and running, it's fine. And there is a lag time of none. This is essentially your RPO, your recovery point objective shows up here. It also shows up in the main DR tab. So on the right-hand side of continuous data protection, there is the ETA and lag column, which indicates none if everything's working fine, or if there is any network disconnection or network saturation, and the data Cloud Endure needs to catch up, any new changes, you'll see what the lag time is, your effective RPO, and you'll see also what the ETA is for Cloud Endure to the Cloud Endure estimate of getting everything to catch up. So you'll see that as well. But assuming everything's going fine, then you'll see none, lag none, ETA not applicable. And now let's imagine that a disaster strikes. So several seconds after the transaction was posted, disaster strikes. Users no longer have access to your source application, and it's time to bring them up in the cloud, to bring up the machines in the cloud and redirect your user traffic. So you can check the checkbox or checkboxes next to multiple machines that you want to bring up in the cloud. Click test or failover. If this is an actual disaster, then you can fail over. The difference is that failover also it prepares the stage for failing back, where test just allows you to bring up the machines in the cloud in order to validate that they're working fine and then remove them. But effectively, it's really the same thing that happens behind the scenes, where the machines are being brought up. There's also a question that you're being asked, which is, what is the point in time of that machine or of those multiple machines that you want to recover to? And the reason that we have this capability is to allow you to recover from other situations different than just a disaster, an unexpected disaster. If you have an unexpected disaster and you want to bring everything up and go back to the point in time just seconds before the disaster, then you just click on latest. That's near zero RPO. But there could be other cases where you have a database corruption that you want to go back and recover from, which may have happened a few hours ago, maybe a few days ago, and you want to recover. In recent times, you also hear about situations like ransomware attacks where your data gets encrypted, and you definitely want to be able to recover from that before your system got infected by ransomware attacks or by other viruses or Trojan horses. So Cloud Endure allows you to do any of that. You can either recover to the latest point in time, to the most recent point, or you can go back. And by default, Cloud Endure allows you to go back conveniently every 10 minutes within the past hour, once an hour within the past day, and once a day within the past month. And that's configurable as needed. For the purpose of this demo, I'll click Latest, select Latest, and then click on Continue with Test. And this is what now initiates the final stage of the process of bringing everything up in the cloud. So far, we talked about the ongoing replication, the initial sync, which is initiated right after the agent is installed, and then the ongoing protection, the CDP, continuous data protection, of the systems after the initial sync is done. And then, assuming that you've already configured where each system belongs, and I'll talk about that in just a moment, then you're ready to go. Everything is brought up in the cloud. And you can see here under the log that everything is now, that process has now begun. So we're grabbing the most recent state of the disks, reconstructing them using the appropriate properties, performance properties in the target location. And after several minutes, everything will be up and running. Now, keep in mind that before you're ready to bring up the systems in the target location, you still need to tell Cloud Endure, and this is something that Astadia does very well as one of our disaster recovery partners, is that within each server, to the right-hand side of that source tab that I showed before, there is a blueprint tab. And the blueprint tab is basically the metadata that Cloud Endure requires that it needs to know about where it needs to bring up each server, where and how, what properties to use when it brings up each server in the cloud. And this includes things like the instance types. So what instance type in the cloud will be associated with that machine when it comes up. So this basically, in other words, is the number of CPU cores and memory associated with the machine. And as the DR deployment takes place, it's very easy to just see what's the right instance when you right-size things, and then change things if something isn't right. So for example, if you have used a small instance type, too small of an instance type, and the machine doesn't have enough memory or CPU cores to function from an application perspective, it's no big deal. You or Astadia on your behalf can go back into the console and right-size it properly. Or the other way around, maybe you've over-provisioned and you're overpaying for an instance that's too large than you really need. So no big deal. If you see that the application can function with less, you can select a different instance type and then bring it up. Same thing applies to the other components. So what subnet you want to bring up the machines in from a networking perspective. So before Cloud Endure is going to be functional from a DR point of view, you or again Astadia on your behalf will need to provision the appropriate networking in the cloud. So create the appropriate VPCs or subnets in the cloud to match the appropriate networking that you have on premise so that the machines know how to communicate with one another when they come up. So the networking needs to be created. The networking then needs to be injected into the appropriate subnet metadata here, the blueprint, and use the appropriate security groups or firewall rules, private IPs, elastic IPs. So you can see all those options here, and so on and so forth. You can also define tagging, volume type, so whether you want to bring them up on cost-effective magnetic storage, or use SSDs or highly provisioned IOPS SSDs. So all that can be defined here. And once that's done, which is what I've done before in advance, then you can bring up the machines just like we've already presented. So check the checkboxes, click test, or click failover, and everything is then up and running. And if I look at the log, what you'll see is that it's done, right? So the whole process started at 33 minutes and 16 seconds. It finished at 34:58. So in my case, it took about a minute and a half to bring everything up end to end. And this includes spinning up the instances, attaching the appropriate volumes, defining the appropriate security groups and subnets and internet gateways, so all and routing tables. All that happens behind the scenes. And when it's done, you'll see that there's a little icon here under status, this copy icon that indicates that there is now a new clone of that machine running in the cloud that you can use. And if I access one of those boxes, either the front-end server or the back-end server, like I've done before, you'll see that there is a new tab that didn't exist earlier, but it exists now, called Target. And this is the indicator that the target machine has been launched. So earlier we only had source and blueprint. Now we also have target because the clone has been launched. And if I access that application in the cloud, let's go ahead and do that. So assuming that it's completed booting and the application is up and running, let's take this new IP address, public IP address that's associated with my app in a secondary region. And if I access my WordPress site in that secondary facility, you'll see that we didn't skip a beat, right? So this was the old server. So IP address 52.11.14.27 that was running in the source site, in the source region, or on-premise, or whatever it is. And then this is the target one, different IP address, same transaction. So if this was just a DR drill, just a DR test that you periodically conduct, then this is the end of the drill, right? So you know that your system is functional in the cloud. You can perform other types of validation tests or have Astadia help you with these validation tests. And then when you're done, then you can, in order to reduce unnecessary costs by the cloud provider, you can go back to the console, check the checkboxes, and under More, there is an option to delete the 2 target instances. So Cloud Endure cleans everything up from the target infrastructure, so you no longer have to continue paying for that. But if this is a real disaster, an actual disaster, then you can complete the process by failing over, have Astadia help you redirect the user traffic via DNS redirection from the on-premise location into the cloud, and then you're done. So now you have everything running in the cloud. Users are seamlessly redirected to the cloud, and once you're done, once the disaster is over, after several days or several weeks when you want to go back, then Cloud Endure will also have a function here that you'll see called Failback, which will reverse the replication direction back to the original machines on-premise, and then it's the same process. It's just redirecting user traffic into the source facility. And that's it. That's what I wanted to show everyone. Again, there's a lot more to it when it comes to configuring the account, configuring the networking. We're not going to spend time during the session to talk about those things, but obviously that's something we'll be more than happy to talk about offline. Help you configure this. You're in great hands with Astadia in terms of helping you assess the source environment and then configure things properly within Cloud Endure and setting up a DR environment end to end. And with that, let me hand it over to back into Desiree.
All right. So now I just wanted to talk to you guys about a wonderful special offer we have for you guys in regards to this webinar. We have 5 free disaster recovery licenses available for the first 5 individuals that reach out to us by going to info@astadia.com. Now let me just walk you through this offer because it's really exciting. What the offer entails is that each individual license will give you 6 months at no charge. That's over $3,000 value in itself. And this offer is limited to the first 5 registrants to request a trial. Along with the licenses comes consulting from both Astadia and Cloud Endure experts, which is over $7,000 value in consulting alone. So a really wonderful package that we're offering, over $10,000 with the actual license as well as the consulting, because we want to make sure that we help you and get you started for success with these licenses. So all you have to do is you go to, in your email, send us an email at info@astadia.com and let us know that you're interested in the disaster recovery license offer, and we'll be sure to get in touch with you. This is definitely an offer you do not want to sit on because we will have lots of people really wanting to get involved and get this. So time is of the essence. All right. So now we're moving on to the Q&A section, but just a quick reminder, if you have a question to ask our experts, feel free to type it into the chat box on your screen. But now let's definitely address some of the questions we've been receiving throughout the presentation. The first question that we received says, what is the frequency of the replication?
So the frequency of replication with Cloud Endure would be real time. So as soon as a transaction is committed, that will be replicated to the staging area. So it should be instantaneous.
Okay, wonderful. Next question, what happens to my replication if the network is interrupted during the initial data transfer?
Gunnan, I'll let you take this one.
Sure, absolutely. Yeah, so Cloud Endurance agent basically knows how to handle any kind of interruptions of network or otherwise. So if the network connection goes down during the initial sync, the Cloud Endurance agent will basically know where it left off, so what block it got to, and also track any new blocks that are being written to the disk during that network outage. And then once the connection is back up, Cloud Endurance knows to read the data back from the disk from the point that it left off, plus take into account any additional changes that were made at the block level and the write order of those blocks so that the data remains in a completely consistent state. So the bottom line is Cloud Endure will handle any kind of situation of networking interruptions both during the initial sync as well as after the initial sync. If the initial sync is done and there is a disconnect, the same process will take place.
Great. Well, that's good to know that you won't lose any data if there is an interruption. Okay, next question. What happens to my replication if the network is interrupted during a continuous replication state?
Yeah, so it's actually similar to what I just described regarding the initial sync, right? So during CDP, it means that everything is now being captured in real time. And if the connection goes down, the agent goes into that same state where it tracks any changes. And we use an in-memory buffer for that tracks the pointers of blocks that are being written to the disk in the write order. And once the connection is back up, then CDP will be resumed. And the only difference, right, between initial sync and continuous sync in this type of scenario is that if this happens during an initial sync, obviously you're not going to have the ability to bring up the machine in DR if the initial sync hasn't completed. But if the initial sync has completed and you're now in CDP mode, you still have the ability to bring up the machine in the cloud in the case of a disaster, even after you have an outage. But if Cloud Endure wasn't able to catch up yet after the outage was over, you'll have a higher RPO, right? The recovery point objective will still be lagging behind until Cloud Endure is able to catch up.
Perfect. Next question. What will be the performance impact on my system if I have if I write intensive database or other busy applications?
So again, that depends on the number of transactions and the size of those transactions. But as long as Cloud Endure has enough time to catch up based on with the network, it shouldn't be that much of an issue. But please feel free to add. Go ahead.
Yeah, sure. So Cloud Endure is basically designed for busy applications, for highly transactional applications. And the reason that we're designed for that is that Cloud Endure, unlike other replication technologies which can suffer from performance impact severely, with busy applications, usually it happens because there are snapshots involved, like VSS snapshots or LVM snapshots or other types of snapshots. With Cloud Endure, there is no concept of snapshots, and snapshots inherently slow down the system, especially if it's write intensive. And with Cloud Endure, in contrast, the CDP replication will basically never write anything to the disk or never freeze writes to the disk, which is what the snapshot does. And this means that we're tracking everything that's going on, every transaction that gets committed to the disk, we're tracking it in memory. So the only impact that will be relevant on the system is what we're doing in memory, which is compressing and encrypting the blocks before we're sending them over, which is minimal, it's like 0.1% CPU impact, if that. And there's never any kind of writes to the disk that are performed by Cloud Endure. And for that reason, performance impact is going to be completely negligible, even with the most write-intensive workloads.
Okay. The next question is centered around scale. How many servers can Cloud Endure launch simultaneously in a disaster event?
Sure.
Again,
so,
this is a Cloud Endure question. Go for it. Go on.
Yeah, no worries. Yeah, so Cloud Endure, the cool thing about Cloud Endure is that we leverage the target infrastructure that we leverage for DR is cloud. So the top public cloud providers, such as Amazon or Microsoft Azure or Google. And so our scale limitations are essentially their scale limitations. And since their scale limitations are virtually infinite, you're in good shape. Right? So Cloud Endure is proven to be able to spin up many thousands of machines in parallel in the cloud. And obviously, what you want to do is ensure that any kind of soft limits are lifted, because even the cloud providers impose certain soft limits of how many instances you can bring up if you don't tell them otherwise. So if you're planning a really large disaster recovery implementation, make sure you speak with your account rep at the cloud provider or have Astadia do it for you, and make sure that those soft resource limits are lifted. But from a Cloud Endure point of view, as long as the cloud provider can give the resources, we will spin them up. We will spin them up in parallel. And there's another cool feature that we bring to the table, which is the ability to, even if the cloud provider cannot provide a certain resource, let's say that even the great Amazon runs out of certain instance types, like no more M3 large instance types, Cloud Endure can be defined with your permission to automatically ask for the next resource up the chain, so like M3 extra large, for example, so that even if we can't get the original one, we'll ask for the next one up the chain. And the intention here is just to ensure that should there be a disaster that strikes and impacts a whole region, and everyone's asking for something at the same time, Cloud Endure still very aggressively asks for the next resources up the chain until we get you the systems up and running very, very quickly.
Excellent. Next question. Which types of operating system versions are supported?
So Alan, I guess I'll take that too. I'm better equipped for that. So on the from a Cloud Endure agent perspective, we support all the common versions of Windows and Linux, and that includes on the Windows side anything from 2003 and above, so 2003, 2008, 2012, 2016, and both the R2 versions as well as the non-R2 versions, the 32-bit and 64-bit. You need to also keep in mind that if the cloud provider doesn't support a particular version, then it's going to be the lowest common denominator. So ensure that the cloud provider supports an OS version from a licensing perspective. Otherwise, you're violating Microsoft licensing rules. And Cloud Endure supports that OS as well. But all the common versions would be supported there. On the Linux side, same deal. So we support all the common distributions like CentOS and Red Hat and Oracle Linux and Debian and Ubuntu and SUSE, and all the common versions as well. So on Red Hat and CentOS and Oracle Linux, it's version 5 or above, and the same thing applies to the other versions and distributions. So all the common ones are supported.
All right. Next question is from John. He wants to know, how is my data secure during transit?
Sure. So Cloud Endure, before the data gets shipped over, so it's captured at the block level on the source environment, and it then gets, if we deem that that block needs to be sent over to the cloud, assuming it's a new block, so we do perform first block signature comparison to see if the block even needs to be shipped over, and if we do deem that that block needs to be shipped over, we compress it, and then encrypt it in transit using 256-bit AES encryption, so we're following all the enterprise standards. And then we can also apply data at rest encryption when the block arrives to the cloud, leveraging the cloud provider's data at rest encryption capabilities.
Okay. Next question is SQL, Oracle, and SAP databases supported?
Absolutely, yes. So those are actually the three of the very common databases that we protect. Remember that Cloud Endure, since we replicated the block level, is really agnostic, so we can support other databases as well. Any other databases or homegrown databases that are not off-the-shelf ones, that's fine as well. But I'd say that the very common ones with our enterprise customers that we support on a daily basis would be SQL servers and Oracle databases, as well as SAP workloads.
Great. And the last question, what are the network requirements needed for the solution to operate?
Great question. So I'll take that too. So in terms of the initial sync, It's really a matter of how fast you want the initial sync to complete, and it's a very easy calculation of how much data do you want to replicate, how well compressible it is, because we do compress it before it hits the wire, and what is the bandwidth, what is the network bandwidth that you have in place. So that's for the initial sync. Right? Once the initial sync is done, we're replicating everything in real time, and then the question is simply whether your network, on average, can withstand the amount of data writes, of changed data writes that are applied to the disk on an ongoing fashion. So if there is a spike, if once a day there is a spike of data that gets written to the disk faster than the network can handle, that's fine. It'll impact your RPO, your recovery point objective will lag behind. It'll go up until Cloud Endure can catch up. And if that's not okay, if that's something that you always want to ensure that you have an RPO of seconds, like always, then you need to ensure that your network is fast enough to never lag behind. But if it's okay that every now and then, during once a day or whatever, the spike to the disk impacts your RPO, that's fine with Cloud Endure. Just keep in mind that it'll take, based on networking conditions, it can take a few minutes for the data to catch up, and then RPO is back to near zero. So the short answer is that as long as the network bandwidth is on average able to accept the changes made to the source machines, to the source disks, Cloud Endure will be able to operate without any issues. But if on average your network bandwidth cannot handle the changes made to the source machines, then it's just a matter of physics, right? It's nothing to do with Cloud Endure, but a matter of physics. You will need to upgrade your network pipe if you want to be able to protect those machines with any application, not just Cloud Endure.
Right. Thanks, Gonan. Thanks, Alan. So this concludes today's webinar. We appreciate having both Alan Alvarez and Gonan Stein share their knowledge on disaster recovery. And most importantly, we appreciate you joining us today to learn more about this topic. We look forward to you joining us for our next webinar. Goodbye.
Thanks, everyone.